Hey, what's up, guys? So today we are going to do how can quadratic equations help us solve some complicated area word problems. Last time we did just generic word problems. Today we're going to do these area word problems that involve quadratics. A lot of different variations of this type of question, but we're going to get right into it. So let's read the do now. Number one, the Smiths have decided to put a paved border of uniform width around their swimming pool. Very good for them. That's awesome. The pool is a rectangular shape that measures 12 feet by 20 feet. Let's stop there. This is the pool here. So this is 12 by 20. So if I were to call this 12, this is now 20. So this pool is a 20 by 12 rectangular swimming pool. The area of the border, okay, so that does not include the pool. Okay, so the area of the border is 68 square feet. And the width of the border is x feet. So the thing that we don't know is how wide this border is. The good thing about a uniform border, this word uniform means it's the same length no matter where you look. So this width or this distance is x. All right, so let's start to go through these questions and see if we can come up with a final answer here. So what do we have? What is the area of the small rectangle? Well, the area is a 20 by 12. So 20 feet times 12 feet gives us 240 square feet. All right, everyone's okay with that? This is 240 square feet. Represent the dimensions of the large rectangle algebraically. So this is where it gets a little complicated. Here we go. What would this entire length be? I want you to think about that question for a second. Pause the video and try and figure out what this entire length would be represented using algebra. Go ahead and pause and try to think about that for a second. All right, the answer is 2x plus 20. Now you might say, what in the world? Why is it 2x plus 20? Well, if this is x, then this is x. This distance is x, this distance is 20, and this distance is also x because it's of uniform width around. So what's x plus 20 plus x? 2x plus 20. And likewise, if this is x going up, down, this is 12, and this is x, then this whole side is 2x plus what? Plus 12. Awesome. So we're going to have a 2x plus 20 by 2x plus 12. So the area of the large rectangle is length times width. Now we're going to go ahead and simplify this by double distributing. So that's going to be 4x squared plus 24x plus 40x plus 240. I am going to combine my like terms in the middle, and I'm going to get 2x squared. Let's see, I'm going to get 4x squared plus 64x plus 240. So that's the area of the large rectangle. The large rectangle. All right, so what do we know? We know the area of the small rectangle, or the border, excuse me, is 68. And we also know the inside area is 240. So the area of the large rectangle is going to be the inside pool. That's the pool area. And plus the 68, and that is the border area. And that's going to give us 308. So, how does this information help me? Well, I know the area algebraically is 2x plus 12 times 2x plus 20. That's the area of the entire rectangle, which is 4x squared plus 64x plus 240. But I know that that equals 308. So the equation that's going to help me solve is going to be 4x squared plus 64x plus 240 must equal 308. All right, so now we are going to start to solve this problem. We are going to move the 308. We're going to get 4x squared plus 64x minus 68 equals 0. Remember, all quadratics get set to 0. Then I'm going to divide out the 4 to simplify. That's going to give me x squared plus 16x minus 17 equals 0. All I did was divide everything by 4. All right, and the last thing I'm going to do is I'm going to factor this. Let me come up over here. It's a little Ariella move where you kind of move stuff with arrows. Awesome. So we're going to move this up here. This is going to be x plus 17 times what? X minus 1. That's factoring by AM. Like we said in the last video, a lot of these area word problems or the regular word problems, they're going to factor nicely just for the sake of helping you problem solve. All right. If I were to set both of these to 0, what's going to happen is I'm going to get negative 17 and x equals 1. Negative 17 cannot be the value of x. Do you understand why? How could you have a length of negative 17? That does not make sense. We are going to reject this solution. But x could mathematically equal 1. So we are going to accept x is 1. So what does the value of that variable represent? It's the width of the border around the pool. So the width of the border is 1 foot. So we just used some quadratics to problem solve using area. All right, so we're going to go ahead and turn the page. We have a few more problems we're going to attempt. All right, so let's just take a look here at this next one, number 2. An elementary school is designing a set of square garden plots so that each grade can grow its own vegetables. The minimum size for a plot recommended for vegetable gardening is at least 2 meters on each side. See, now you all learned about garden sizes. Sweet. The school principal has decided to make the gardens bigger by adding an additional X meters on each side. So let's write an expression that represents the area of one garden. Well, it was originally 2. That's the minimum size. But our principal wants to enlarge to maximize space, so we're going to add X to both sides. Remember, he's going to add X meters on each side. So the area is length times width. Now in a square, it's just side squared, so we're going to multiply this by itself. Now I'm going to double distribute and get x squared plus 4x plus 4. So that's the expression that represents the area. Expression should not have an equal sign. All right, there are 6 grades in the school, including pre-kindergarten and kindergarten. Write an expression to represent the total area of all 6 gardens. Well, that's pretty easy. All I have to do is multiply this by 6. So I'm going to get 6x squared plus 24x plus 24. Awesome. The total area available for gardens is 150 square meters. So we want to find the dimensions of each square garden. So I know that all 6 areas have to be equal to 150 in order to maximize the space that we're using. So I'm going to say that 6x squared plus 24x plus 24 must equal 150. Now we are going to subtract this 150 to the other side, and we are going to get 6x squared plus 24x minus 126 equals 0. Fortunately, and not coincidentally, all the numbers divide by 6. So we're going to get x squared plus 4x minus 21. That is called simplifying an equation, where you divide everything by the same number. 0 nicely divides by everything, so we always end up with 0. And we're going to take this off to the side, and we are going to factor. Take a minute and factor that expression right here, x squared plus 4x minus 21. We'll set it equal to 0 for a nice equation, and then we will solve. Good. If you said x plus 7 times x minus 3, you are correct. This is going to give you an answer of -7, and this is going to give us an answer of 3. Now, which of these makes most sense? Could the principal have added -7 feet to each side? Of course not. But could the principal have said we're going to increase by 3 feet? Maybe he just wanted to know what's the amount I can add it by so that I take all 150 square feet. Well, we can use math to figure out that missing number, and that missing number is 3. So we're going to increase by 3, so each garden is 5. Actually, it's not in feet, it is in meters. 5 meters by 5 meters. Remember, they are squares. 3 plus 2 is 5. All right. I would take questions, but we all know that's not possible. Distance learning at its finest. We are just going to keep rolling and hope for the best. Number 3, the length of a garden is 8 feet longer than it is wide. Now, a good geometry teacher will always tell you, you need to draw diagrams. Pictures are really, really powerful in helping you understand a question. So we're going to go ahead and draw a rectangular garden that is 8 feet longer than it is wide. So I'm going to just say if it's x feet wide, it is going to be x plus 8 feet long, which is 8 feet longer than whatever that is. Now a walkway 3 feet wide will surround the entire garden. So that's going to kind of go around the garden. Now I know that that is 3 feet wide. Okay. The total area of only the walkway is 288. What are the dimensions of the garden? I want to star this one. I think this one is the trickiest one on the page. It does involve you to think a little bit harder than it is in the other ones. So let's think about this. The walkway is 3. So this is 3, and this is 3, and this is x. So what's the whole side of this side? That's going to be x plus 6. 3 and 3 make 6. Now let's use the same logic. Now I'm going to stop right here. This is 3. This is 3, but this is x plus 8. So this whole side is x plus what's 8, 3, and 3 make? That's 14. So we're going to have x plus 14. Now, the total area of only the walkway. All right, let's think about this. How would I get the area of the walkway? I would need to do this. I would need to find the area of the large rectangle and subtract the area of the garden. Well, the area of the garden is x times x plus 8, or length times width. So that's x squared plus 8x. The area of the entire plot, the garden plus the walkway, is x plus 6 times x plus 14. That's going to give us x squared plus 14x plus 6x is 20x, and 14 times 6 is 84. So that's the area of everything together. All right. The area of the walkway is 288. So let's take the entire area and subtract the garden. And that's going to give us the walkway's area. Don't forget we need parentheses. When you subtract a binomial, you need to put it in parentheses. So x squared minus x squared is gone, so we get 20x plus 84 minus 8x is going to be 12x plus 84. All right, so what do I do with that information? This is the area of just the walkway. That's important because we know that the area of the walkway is 288 square feet. So I'm going to say 12x plus 84 must equal 288. And I'm going to subtract the 84. That's going to give us 207. I'm going to divide out the 12, and that's going to give me 17. All right, so what we just did is we figured out the value of x. X must be 17. The dimensions of the garden are 17 feet by, what's 8 more than 17? And that gives us 25 feet. So the answer to the question is 17 by 25. And we didn't solve it using some guess and check method. We used quadratics, we used math, and we figured it out very nicely. So that's number 3. All right, let's get into our last question of the day. Is number 4. A museum is displaying Egyptian artifacts in a 34 by 10 foot rectangular garden. Think to yourself, what would I ask you to do right now? You are right. I'm going to ask you to please draw a picture of this rectangle. 34 by 10. Now, that gives us an area of 340. We're in feet, so square feet, right? To protect the artifacts, a roped-off border has been created around the display. So let's just rope this off. We're going to rope that off. The combined area of the display and the border totals 640. Find the width of the border. So what do we not know? We do not know the width. And just like we did on the do now in the front page, this width is x. And this width is x. So this whole side is 2x plus 10. And this whole side, in similar argument, is going to be x plus 34 is 2x plus 34. And the total combined area is 640. So the length, which is 2x plus 10, or the width, doesn't matter what you call what, these are arbitrary distances, is equal to 640. And all we're going to do is we are going to solve, let me just tape this down, we are going to solve this equation for x, and that should be done. So let's do it. We're going to double distribute here. So 2x times 2x is 4x squared plus 64x plus 20x plus 340. There's an x there, equals 640. What do we do with any quadratic? How do we solve any quadratic? We need to set it equal to what? 0. So let's subtract the 640 over. That's going to give us 4x squared plus 88x, if I combine my like terms, minus 300 equals 0. Please check to see if everything divides by 4. And if you do that, it will, and you will end up with x squared plus 22x minus 75 equals 0. And the last few steps here are to just solve this. So we want to just solve this guy for x. So we're going to get x plus 25 times x minus 3 equals 0. This is going to give us negative 25 as a 0, and this is going to give us 3 as a 0. Which one makes more sense? This is a reject. We are going to reject the negative answer. It does not make sense in the context of the question. We are going to accept the 3. So the width of the border is 3 feet because x was the width of the border in our diagram is what we're looking for. All right, so we admit these questions are not the easiest ones. They're a little tricky. You do need to maybe watch this video or parts of it a second time and slow it down, process what is going on. Please try the additional problems in the Castle Learning questions and do your best. Ask questions, comment on this video, or email your teachers, and we will gladly get back to you with some help. All right, I hope you are enjoying a beautiful day out there today, and we'll talk to you soon.